Hi, it's Ftrhstry, coming to the 2020s from the 2120s via timey-wimey vortex. Talking today about interstellar tardigrades, blasting off little bitty bacteria via laser-propelled, wafer-thin spaceships to our closest neighbouring star and those beyond. This bounces off a pitch by Philip Lubin and Joel Rothman, some scientists at UC Santa Barbara, and they're publishing in Acta Astronautica an idea about specifically putting little tardigrades or moss piglets or water bears on little wafer-thin spaceships, which they will then propel with blasty lasers to up to 20 to 30% of the speed of light. And that could get them to Alpha Centauri and its buddy stars and planets in about 20 to 30 years, they think, given exponential advances in the technology of the photonics that are, propelling this spaceship array. And it turns out from the future that they're right. We do in fact get much better at this. And so by the 2060s, in most timelines, Earth can expect pictures or at least data coming back to it from Alpha Centauri, and in the decades later, other stars beyond even that. So for comparison, the furthest things in the 2020s from Earth that Earth has sent somewhere are the Voyager spacecraft. They're about the size of a car. They've been moving at like 35,000 miles an hour, and they are just outside the heliosphere, which is sort of like the solar wind bubble that contains Earth's solar system. And that's about 12 billion-ish miles away. And if they were to continue at their current speed and somehow get to Alpha Centauri, they would take 80,000 years to do that. So to get there in 20, 30 years, it's really big, exciting potential accomplishment in the 2020s. And in the 2120s, it turns out to have been, yes, very cool. And the way they do this, again, they blast the little chips with lasers. You may have heard about this in the context of some other planned missions. Mid-range, what does this mean futurologically? It means it's happening from Earth in like the 2030s. These projects start actually getting off the ground, going into space. Late 20s at the earliest, 30s, the science is coming into its own. Then the 40s and the 50s, everybody's sort of waiting, checking their phones, starting to launch other little deals like this. And then the 50s and the 60s and the 70s, we start getting information back about these tardigrades and about the planets and stars that they're visiting. The tardigrades themselves and other bacteria like this are incredibly durable. That's why they're being pitched as potential astronauts. They can live in super dry conditions, super pressury conditions. They can even withstand massive amounts of radiation. They can dry out completely for sustained periods of time, but they only live for around 2 years in natural conditions. So to take a journey like this, they would be sort of biosuspended, quite cold, I would imagine, and then zapped back into life just to sort of get a picture of how their survival goes in this neighbouring system. And of course, there's not very much for them to do there, because if they were to, say, like, discover a planet with life, they would burn up in the atmosphere trying to land there. So they're not going to do that. They're just going to go visit. And in the future, lots of different accents, as you may have noticed, blend together into the UK and, in general, English-speaking linguosphere. Where does this go in the longer future? To other stars is the very short answer. Like, it turns out we focus on Alpha Centauri a lot because it's the closest one. But then there are, like, this Barnard star right around the corner at just a little farther away, like another light year past them. And then there are other stars in the 7, 8, 9, 10, 11 light year range. So it's not like we're totally alone on an island. We can keep pressing this out. And by the 2120s, we have got probes in many more of these places. So we've got much more information than just the telescopic reads of our sort of neighboring solar universe, which is, pretty cool. And in the practical upshot, this tells us a lot about the way life evolves in other places in the universe. One of the coolest ways in which the 2120s are different from the 2020s and 30s and other bits of the early 2000s is just our awareness of the pluripotence of life in the universe. And to that point, when we start talking about zapping little bits of life around the universe, it leads quite naturally to an engagement with the idea of panspermia, which is this theory that life has been bopping around the universe, landing on different rocks, coming from different places. And when you think that we, as a baby civilization, are already doing this, it's very difficult not to think lots of other civilizations have probably done this too and will probably continue to do this, especially since we'll probably continue to do this and certainly do. Also in the 2120s, we've got better wormhole tech and little warp bubble stuff that's going to eclipse some of these probes, just like these probes are going to eclipse the more standard fuel and gravity launch, what you call it, slingshot methods of the Voyager craft. So each generation of technology sort of outpaces the previous one, and we get further out into the universe. We sort of lap some of our probes, but it's still worth pushing the limits. So I recommend checking out some of this information about laser-propelled crafts, because it also becomes a hugely important method of moving stuff around just inside of our solar system, getting to Mars within a month, for example, or getting to some of the icy giants quicker. And it becomes, with our base around the sun and even moving planet to planet, a major way that we move stuff from place to place. And the tricky bit, actually, when we're moving between planets, becomes slowing something down from the other side. As far as these tardigrades, they don't get to slow down, so they're going to blast right through the Alpha Centauri system and keep on going into the dark, cold night. Brave water bears, mighty moss piglets, we salute ye, and we proudly ponder the expansion of life into the great, beyond, and unknown. I recommend digging deeper on panspermia, which we might revisit for a little more detail here. And also just go ahead and look up the next 50 closest stars to Earth, because it might give you a bigger sense of our neighborhood, and you might, as a result, feel slightly less alone, which is always a good thing to feel. So I see you feeling alone. I feel alone myself sometimes, even algorithmically, even in the dead, cold, far-flung future. So a bit of love will never go amiss. Love me, love you, love life, and see you soon. Ta.